Okay, before we get started, I want to ask, is it okay if I record?
Yes.
All right. First of all, if you're here, welcome. This is another episode in the Hawkins STEM Chronicles. If you're here, you're a scientist. If you're here, you're a technologist. If you're here, you're an engineer or a mathematician. Doesn't matter whether you're doing it professionally, doesn't matter whether you're studying in school, doesn't matter whether you're just curious about STEM. You're welcome. We're glad you're here. And if you see the benefit of this kind of material, please like and subscribe. Now, I have a friend here with me. And for the record, state your name.
Hi, I'm Elizabeth.
Now, Elizabeth, if you would, you're bringing something to this episode that really haven't done before, probably should have done a long time ago. In addition to being a STEM student, you're also an educator.
Yes.
But as an educator, you've taught STEM in
Yes.
school. So one of the things about STEM is the scientific method.
Yes.
So what I'd like you to do for the first part of this, so I'm going to ask you basically if you were going to explain STEM to a kid from say first grade to sixth grade, what would that explanation for the scientific method be? If we were in junior high school, would that explanation change? If you're in high school and college, would that explanation change? So when you start, talk to us all like we're between 6 and 12 or 6 and 13. Please explain what the scientific method is.
Okay, so if we're starting 6 and 13, there's a huge difference there. But
Okay.
if we're going to start earlier, we had talked about explaining things to my nephew who's just entering kindergarten. And if I were to talk to him about the scientific method, I would begin to introduce some of the vocabulary, and at the same time, I would explain what that vocabulary is. So I would explain that when we're doing science, what we are doing is first we're going to come up with sort of an educated guess. We're going to learn as much about what we're making our guess about as we can, and then we're going to make a guess that we can either prove or not prove, and that is a hypothesis. And so we're going to take that hypothesis and we're going to say, okay, how can we design an experiment that will prove or not prove our hypothesis? And it needs to be based on information we already have. So, it's not going to be something really out there like, something that has absolutely nothing to do with one thing, and then does this affect this? Well, first we need to say, okay, are these two things even connected? And then look at that. But we're looking at, okay, using our hypothesis, the example that I had given when we were talking earlier was if we took bean sprouts, and I know that some things that are important to plants growing, I know they need sunshine, I know they need water, I know they need soil, I know they need space to grow. And so if I take 3 pots and they're all the same pot, and I use all the same soil in the pots, and I plant a bean sprout in each pot, and then I say, okay, I'm going to measure how much water. Does it make a difference how much water I give this bean sprout every day? And one bean sprout I'm going to give half an ounce of water to per day. And one bean sprout I'm going to give an ounce of water to per day. And one bean sprout I'm going to give 2 ounces of water to per day. And then each week I'm going to measure how tall has my bean sprout grown. And then I take that information and I organize it. And then after I organize that information, then I look at whether or not my experimental data supports my hypothesis or doesn't support my hypothesis. And if it supports my hypothesis, then I've learned something new. And if it doesn't support my hypothesis, well, I've learned it doesn't support my hypothesis, and that I need to take a look at my hypothesis and look at what needs to change based on the data.
Okay. So now, what are the steps in the scientific method?
So you start with a hypothesis. Then you go to experimentation. You take that experimentation and you look at the results, and then you try to see if other people can replicate your results. And so this is how we set standards for what is true and what is not true. So when I look at information coming from scientists, I know that it is based on this process of making a hypothesis based on what we know and what we don't know, and identifying what we don't know, and then doing experiments to see if we can clarify what we don't know and refine that information, and then seeing if other scientists can replicate this experimentation and see if it works all the time.
So one of the pieces of the scientific method is observation.
Right.
Talk us through the observation piece.
Okay, so when we're watching, the part that we talk about the most usually is experimentation, because it's very easy to come up once we've got our hypothesis, then we try and isolate our variables and experiment with our variables. But before we do that, we have to know as much as we can about what we're going to experiment with. So we can use instruments, like we can use a magnifying glass to see what the bug looks like under the magnifying glass, what a leaf looks like under the magnifying glass, seeing as many details as we can see. We can sit and we can watch. So for instance, what plant does the butterfly like to land on? How does the butterfly fly? How does the moth fly? Are there differences between how the moth flies and how the butterfly flies? Are there differences between what the moth eats and what the butterfly eats? What are the behavioral differences? One of my favorite stories about maple syrup, and this sounds really random, but it's really about observation. When European people first came to the Americas, they asked Native Americans, well, how did you learn that this tree gave you sweet syrup? And they said, the squirrel taught us.
So in other words, you're observing, and you're making decisions, you're judging, you're evaluating
Exactly.
what you're seeing. And so now there is the recording piece. When do you start writing down what you're observing? When do you start writing down your general idea about what you think is going to happen? And then you test it.
Well, what I start doing, a thing that my husband always used to say, because the two of us met in Latin class. And so he would say non scriptum non est, which
Yes.
means
He
if
didn't
it's
write it
not
down.
written down, it doesn't exist. So you need to start writing down as much as you can. One of my favorite things to do is I have a lot of drawing journals, and even though I'm blind now and can't see as well, what I used to do is draw a lot, and then I would put notes on the edges of my drawings. And so observing just as much as you can and writing that down in one way or another, whether it's by drawing, whether it's by writing down words, putting down your observations as best you can is very important. And I would always encourage my students to have a science journal. I would, at the beginning of the school year, one of the things that I think everyone kind of knows is that teachers spend a lot of their money on materials for their classroom. And one of the things I used to do is at the beginning, whenever Staples has their big beginning of the school year sale, I would be in there buying 50 notebooks. I need my 50 notebooks, and then I would send off to a pencil company, and I would buy like 11 gross of pencils to get me through a year. I had essentially my own little warehouse of school supplies, and one of the things that I would do for my students is we would have a day where we would just decorate the outside of a journal, and that journal was our observations journal. And we would just write down whatever we could write down, draw whatever we needed to draw, do what we needed to do so that we had the information there and we could just look at all of the different things that we saw. When we planted a school garden, I encouraged my students to go and write down all of what they could remember about the process of how we had started our school garden, and write down all the different animals that they saw, the different insects that they saw. How are the deer behaving when they see our freshly planted plants,
Now, talking about the scientific method and explaining it to kids, that's one thing. If you were talking to someone in college, let's say someone who had never taken a chem class, never taken physics, never taken whatever, how would you explain the scientific method to that person?
Well, the first thing that I would explain is that, to me, one of the things that I studied in college, I wound up studying history. And so I look at science, and before we called it science, which just comes again from the Latin scire, to know. So what it means is science is the philosophy of how we know things. And so before we called it science, we called it natural philosophy. And so, again, science is how do we know things? So how do we prove that something is true or it's not true? And what are we using to judge whether something is true or not true? And how do we separate the true from the not true?
Okay, now, as silly as this is going to sound, but it's silly, but at the same time it's not off topic.
Right.
Have you ever heard of Monty Python?
Yes.
Okay. There is this, I guess it was one of the movies, where the knight rides up and there's some villagers. And he's like, well, what are you doing? And he says, we're going to burn a witch. And
How do you know she's a witch?
because we say she is. That's not science.
That is not science. And when she's coming back at them saying, you know, this isn't my nose, this is a carrot that you strapped to my face. And they're like, well, that doesn't matter, you know. And so if you're going with, you have, as I said earlier when we were talking about the hypothesis, either the data supports your hypothesis or it doesn't support your hypothesis. And if it doesn't support your hypothesis, but you're still insisting on it, that's not science.
So now let's take this out of academia and let's take this out of the classroom.
Mm-hmm.
Is it true to say that regardless of whether you've ever been in a science class in your life,
Mm-hmm.
that you use the scientific method?
Well, it depends. Part of what I would say, because there are times that people absolutely are not using the scientific method. They're just going with, you know, another famous story of science is, of course, "E pur si muove," which is when Galileo said, and yet it's still moving.
Yes.
You know, we don't know whether he actually said that. I kind of doubt it because, you know, the Pope could have had him killed.
Mm-hmm.
But I love the idea of this story.
Mm-hmm.
Because it demonstrates, you know, here's the Pope, and the Pope is saying what is true is based on, you know, what someone wrote hundreds of years ago, and that's how we know that it's true, because it was written hundreds of years ago. And Galileo's saying, yes, but this is what I saw with my own eyes. This is what I observed. I observed that the moon is not perfect. It has pits in it. It has craters in it. I observed that Jupiter has moons. So this idea of the spheres doesn't work.
Mm-hmm.
You know, I've observed that there are all of these things that we can see. I've observed that Venus has phases.
Mm-hmm.
So all of these things, anyone else can look through a telescope and they can also see these things. Although one experiment of Galileo's that I do not recommend anyone replicates without proper eye protection is he looked through a telescope at the sun and saw sunspots. And so Galileo died blind. Don't do this, boys
Don't do
and
this at
girls.
home, folks.
Right.
So another way to approach this is, like you said, we may not all know what the scientific method is, but we can all understand and then apply the scientific
Yes.
method.
And that's the thing. If you are basing what you know on what you can see, how you interact with the world, you know, I could take this piece of wrapper and, you know, I could sort of replicate that famous thing that Newton did. Boom, it goes down.
Yes.
Why does it go down? Because it is attracted to the earth through the power of gravity.
Now, thinking about this from another way, if we want to, obviously looking up the scientific method, you can Google it, you can go on ChatGPT, look it up.
Mm-hmm.
But let's say in popular culture, what are some episodes in popular culture that people can see people apply the scientific method?
One of my absolute favorite films of all time is, honestly, How to Train Your Dragon.
Okay.
Because, in my opinion, How to Train Your Dragon is a love letter to the scientific method. If you haven't seen it, go see it.
Okay, I will. I've seen the scientific method used in Star Trek.
Yes, frequently.
And I've seen the scientific method used a lot in Sherlock Holmes.
Yes.
So, and obviously some of this is abbreviated because you're only talking about either an hour movie or a 2 hour movie
Right.
or whatever. But the important thing is you observe something and you're trying to understand what you're observing.
Exactly.
And like you said, you come up with your questions. And well, gee, if one thing that answers this question is this idea, and
Right.
this idea is the hypothesis, now we got to test it.
Exactly.
And you're writing this down all while you're doing it. Shameless plug for DC Public Schools, but the most important thing I learned in the 7th grade was the scientific method.
Yes.
Well, Elizabeth, I want to thank you. And for those of you who are watching this episode of the Hawkins STEM Chronicles, it's important to know, yes, that you're welcome. It's important to know that, yeah, we want you back, but it's also important to get you to like and subscribe to this. So please, again, hit the like button, hit the subscribe, because you know how the algorithms work. Again, Elizabeth, I want to thank you for your time, and I want to thank you for what we've learned from you. So you're still teaching.
I love teaching and have loved teaching my entire life.
And you're going to see a buddy of mine a little bit, and you'll be still teaching him.
Yep.
All right, well, thank you. Thank you so very, very much.